Chapter 11, Section 2. Let's see what we have to discover today. Next shape. This chapter, again, is going to be about a lot of different shapes and formulas for area and perimeter, stuff like that. Trapezoids. Do you remember what the definition of a trapezoid is? Make sure we can recognize a trapezoid. Two parallel sides. One pair of parallel sides is how we say it. The other sides are not parallel. So there's exactly one pair of parallel sides. And the height of all of our figures are going to be altitudes. I need to go from, when they have bases, I need to go from one base perpendicular to where the other base is, and that's where the height is going to be. Now I've drawn this little dashed line in that trapezoid, which has divided that trapezoid into what? Two triangles. Are those triangles congruent? No, they are not the same size. Remember on the parallelogram, we chopped off a triangle and all we had to do was slide it to the other end and then it would make a perfect rectangle? Doesn't work here for a trapezoid. These things are not exactly the same size. But I can use the area formula to figure out the area of triangle 1 and the area of triangle 2. Now I'm going to call this bottom one base 1, and this one I'm going to call base 2. Is base 2 something that I could use as the base of triangle 2? Yeah, I could use it for the base of triangle 2, and then the height of triangle 2 would be that line right there. Is that the same as the height for triangle 1? Yep. Yes, they're the same heights. So let's write the area formula for a triangle. 1/2 base times height, and it would be base 1, if I'm doing triangle 1, times its height. Plus, triangle 2 would be 1/2 base 2, because it has a different length base, but it has the same height, so I can use the same letter. Now, if we use a little algebra and factor out things that are common, what do you see common in these two terms? H is common. What else? 1/2 is common. I'm going to factor out a 1/2 and an H, and I'm left with what from the first term? Base of 1 plus base of 2. And guess what we have made? A formula that is the area formula for a trapezoid. That's where it comes from, right there. So as you memorize this chapter, thank you, ladies and gentlemen, for your formulas, there's your next one you need to have memorized. So now you've got it. 1/2 the height plus base 1 plus base 2. Another way of looking at this, what does it mean when you take half the sum of two numbers? What have you found? The average. Another way of thinking of this is it's the average of the bases times the height. It's the same thing. Automobiles. Well, if you have a flat front windshield, this would be true. Most of us have curved windshields, but that's okay. Find the area of glass used to make the windshield of a van shown at the right. We will assume this is a flat one because it catches bugs better. Area equals, what's the formula? No numbers. Well, unless there's a number in the formula. 1/2 H. Base of 1 plus base of 2. The more you write it down, the more you have memorized it. Do your studying each day. That's how I do my studying. I write it down, and by the end of today, I remember this formula. Hopefully I already do, but because I did that in the past. So fill it in. 1/2, what's H? 38. What's base 1? 72. How do you know it's 72 and it's not 85? Doesn't matter. Doesn't matter. You can say base of 1 is smaller, base of 2 is bigger, or base of 1 is bigger, base of 2 is smaller. Does not matter. You run that through your calculator, what's the area for this windshield? $2,983, exactly. Inches square. Owen designed the silver eel rings shown. They are shaped like isosceles trapezoids. What does that mean, isosceles? Congruent. Do you remember what those side legs, we call them? Congruent legs. They have congruent legs. What is the area of each earring? Oh, I shouldn't have, whoops. I shouldn't have left these things here. That gives you too much of a clue. We have isosceles ones, and we want to find the area of each earring. Well, if I'm going to find the area of the earring, I have to know the, what is my missing? I have to know the height. I do know the height is going to be found right in here. Do I have enough information to figure out the height? Not quite. Now, maybe if you were paying attention, you could tell me what I should do next. Maybe I was quick enough and you didn't see it. I had another line drawn. Where did I have it drawn? It was right over here. What good does that do me? Since this is isosceles, these things are exactly symmetrical. These are congruent to each other. So I know right in the middle is 2, so I must have a 1 here and a 1 here because I know the whole thing is 4. Now I have figured out enough information that how could I get the height? Pythagorean Theorem. That height is one of the legs squared plus, what else would I need? 1 squared will equal 3 squared. So we can figure out the height if I subtract my 1 squared, 3 squared minus 1 squared, and then took the square root of it. What's 3 squared? 9. What's 1 squared? 1. What's 9 minus 1? 8. Square root of 8. I'm just going to leave it written square root of 8. That's the exact value. I don't need to mess with any rounding error when I do things like that. So I can now fill in my formula. Area of a trapezoid is 1/2 height times base 1 plus base 2. So if I take 1/2 the height, what was the height?
8.
Square root of 8. Square root of 8, we figured it out. What's 1 base? 2 or 4. Doesn't matter what you want to use. Now let's take this. Do they say where to round? I guess we'll go to the nearest tenth since they didn't say where to round. Let's see what you get. People want to agree. 2 plus 4 is 6. Half of 4 is 3.
6 square root.
Okay. The exact value, yeah, let me keep going with the exact value, putting in the calculators a little bit. 3, 2 and 4 is 6, half of 6 is 3, 3 square roots of 8. The square root of 8 can be simplified. Oh, forgot my 3. 4 times 2 is 8, and the square root of 4 is 2. 3 times 2 is 6, square roots of 2. There's the exact answer. 6 square roots of 2 centimeters squared. What's the approximate answer? 8.5? 8.5 centimeters squared. Don't forget your ability to simplify square roots. Next shapes, rhombus and kite. What's a rhombus? It is a parallelogram. What's a rhombus? A quadrilateral with 4 congruent sides. That's all it is. That's a rhombus, always. A quadrilateral, 4-sided figure, all 4 sides are congruent. It's a rhombus. What's a kite? 2 pairs of adjacent congruent sides. We don't want 2 pairs of opposite congruent sides. What would that be? Parallelogram. 2 pairs of opposite congruent sides is a parallelogram. 2 pairs of adjacent congruent sides, congruent, not parallel, is going to make a kite. Okay, so let's talk about a kite and a parallelogram. And the nice thing about a kite and a parallelogram is they have exactly the same formula. The area equals 1/2. What do they say this d sub 1 and d sub 2 stands for? Diagonals. It's kind of convenient when we read it right there. Diagonals. 1/2 diagonal 1 times diagonal 2. So let's remember some things about diagonals. In a rhombus, this first figure is a rhombus. Can you tell me anything about these diagonals? They are perpendicular to each other. That's important. Anything else about those diagonals? They bisect each other. That is true as well. That might be important when I'm talking about a rhombus. Can you think of anything else that's true about the diagonals of a rhombus? They bisect the angles as well. I'm not going to draw all of it in, but they bisect the angles as well. So if you have a rhombus and you are needing to draw diagonals, thank you, ladies, then all of those facts could come into play. So if I know one length on one side, I know what the other length is. Or if I know the total angle, I can cut it in half. And I know the measure of one of those angles. I know I have right triangles. So all those facts about the diagonals of a rhombus may be useful in order to arrive at what the diagonal measures are so that we can do our formula. How about in a kite? What is true about the diagonals in a kite? They are perpendicular. Nate, I missed what you said. What did you say? 90-degree angles. They're perpendicular. What else is true? The diagonals in a kite. They bisect one pair of angles. Right here we're bisected, and then on the other side. So it does not bisect this angle. They bisect the angle that's formed by the congruent parts. So our congruent parts, the diagonal that comes through here, is going to bisect these two angles. Those are the true things about the diagonals of a kite. They're not bisecting each other. They don't have those other things going on. And I need to change this to 2. Switch my color. Because those two angles are not the same size in a kite over there. All right. So let's try it out. We are supposed to find the area of each rhombus or kite. We know our formula is 1/2 diagonal 1 times diagonal 2. So hopefully it's real straightforward. What's diagonal 1? How much? May have heard the right answer, but I have heard wrong answers. What's diagonal 1? It's not 7. It's not 6. 12 would work. Why 12? The whole diagonal. If I have 6 here and 6 here, I need the whole diagonal. So what's the other one? 14. Does it matter which one I call diagonal 1?
No.
No. What's the answer? 84?
Yep.
84 millimeters square. Right over here, same formula. I know the area is 1/2 diagonal 1 times diagonal 2. So what is diagonal 1? 16 works for me. What's diagonal 2? 9. Again, doesn't matter which is diagonal 1 or diagonal 2. No. Answer here? 72 inches square, the area of that one. Remember, we're talking about the whole diagonal, not just part of the diagonal. So they may give us part of one figure or part of another figure. This is like what we did last class period, where they had given us an area. So start out with the area formula. Fill in what we know. Do I know the area? 92 equals 1/2. Do I know one diagonal? 22. Do I know the other diagonal? X. Thank you. Half of 22 is what number? 11. So when you divide, eight point four? 8.4. Ladies, am I missing something? Are you helping each other in geometry? All right. From up here, it sounds a little distracting. Inches. If I do this one over here, area equals, what's my formula? 1/2 height, base 1 plus base 2. That one's a trapezoid. We better use the trapezoid formula. So they tell us the area is 177. Do I know the height of this? 13. Do I know a base? 11. And the other one is x. So here's how I would approach this problem. I would eliminate my 1/2 by doing what? Multiplying by 2. So we can multiply this one by 2. Then I could divide it by 13. You see what I did? I multiplied it by 2, divided it by 13. Have you gotten this number? 20, 27.2. And all that is left is subtract by 11. 16.2 centimeters. I'm assuming you gave me the right number since you guys are the one calculating, but I'm sure you're good. What is the area of the kite shown? Now we have to figure out where the measurements are indicating. This 10 is referring to that right over there. The 6 is referring to this line right here. There's the 6. The 17 is referring to that right over here. So you'll have to be real careful. Sometimes it's not real obvious where they're referring. The reason I knew where the 6 was referring, at least I think, there was a dark line there. I'd have to look to make sure it was. I need to know the what in order to get the area. I need to know the diagonals. 1/2, diagonal 1, diagonal 2. So maybe I'll use, I heard the Pythagorean Theorem. Let's even go shorter than that. Is that a triangle that I can do a shortcut on without having to go through the Pythagorean Theorem? It's a 3, 4, 5 triangle. 3 times 2 is 6. 5 times 2 is 10. So what's this one? 4.
Like how?
3, 4, 5. 8. 8. Does that make sense? 3, 4, 5. W3, W4, W5. 8. So I know one of my diagonals. How am I going to get my second diagonal? 8. Say that again. 8, 15, 17. If you remember, yes. Why do we need to change that 8 to a 16? I need the whole diagonal, not half the diagonal. And this 15? Why is it 21? Why isn't it 30? Yeah. 15 and 6 make that diagonal. So this one bisects. This line bisects. So that's 8, that's 8. But this one is not bisected. Half of 16 is 8. 8 times 21 is going to give you how much for the area? Is that right? Okay. Little summary. You see the page in your book? You might flip to page, what page are you on? 792. That is a very convenient summary of all the formulas you should have memorized at this point. So let's do some of these problems. Page 793. Starting with number 1. Directions. Find the area of each trapezoid, rhombus, or kite. Number 1, formula.
Area equals 1/2 height.
I'm going to wait a minute. I really need your attention here. So even though you may be talking about geometry, now's not the time to do that. Thank you. I want you to write down the formula and then put in the values. Again, that's how you memorize it. This is your studying time. Don't put it off until the night before the test and try to learn all this stuff. Learn it a piece at a time. What's our height? Do we know? 12. And our bases are 6 and 16. So all we need to do is fill in the formula that we know. We know half of 12 is 6. We know 6 and 16 make 22. So we get an area of, how much? 132. What was our unit? Feet squared. Number 2, our shape is called a, it's a rhombus. So they're not going to try to trick you, so that's a rhombus. So what's our area formula? 1/2. Diagonal 1 times diagonal 2. So if I fill it in, what would we call one diagonal? 10. What would the other diagonal be? 18. So kind of nice here. So that is going to give us 90 meters squared. Shape for number 3 is a kite. Formula is same as the rhombus. 1/2 diagonal 1 times diagonal 2. So, do I know one diagonal? Oh, they're too easy. 21, and the other one is 17, and so that gives us an area of 178.5. What's our unit? Meters squared. Here, get my 0.5 out there. Number 4. Stookie is doing fashion design at 4/8 Club. That wasn't a joke. Her first project is to make a simple A-line skirt. How much fabric will she need according to the design at the right? I'm glad she's working on an A-line skirt instead of a B-line skirt. You always want to aim high. Okay. Looking at that thing, what do we have here? We have a trapezoid. We have a trapezoid. So that's the first thing I need to figure out. Okay. What do I know, or what do I need to figure out? Do I know the height? Yeah, what's my height? 2.5. Do I know one base?
Yes.
Which one? Well, 1.5 is the top one. We certainly can figure out both of them. What do I do to get the second base? Yeah, add 1.5. Just drop it down there in between those 2 quarters. So what do you get? 2 when you are done. So what's the area of our A-line skirt? Does it stop?
Yes.
That's the exact answer. Was it measured in feet? Feet square. Let me back up on this one, and let's work with some fractions a little bit. Sometimes we expect the answer to be in fraction form. So if I do the same thing, but write these as fractions, 2.5, not a mixed number, but an improper fraction is what? 5 over 2. That's 2.5, 5 over 2. 1.5, improper fraction, not a mixed number. 3 over 2. 1.5 is 3 over 2, plus 2. If I take a half times 5 halves, when we multiply fractions, 1 times 5 is 5, 2 times 2 is 4, 5 fourths. Now in here, I'm going to get a common denominator. My common denominator would be 2, so I have to change the 2 to 4. 4 over 2 is 2. 3 over 2 plus 4 over 2 is 7 over 2. When I have fractions, again, I just multiply straight across. Numerator times numerator. 5 times 7 is 35. 4 times 2 is 8. It could be written this way, or it could be written, let's do a mixed number. How many times, Spencer, does 8 go into 35?
8 goes into 35.
Thank you, gentlemen, for your attention. 8 times 4 is how much? 32, and what's left over? 3, so I put it over 8 feet squared. Be able to work with fractions. It's not hard, just take some practice. So if you practice, then you get better at that. Number 5. They have given us areas, so we are going to start by writing our formula and filling in values we know, figuring out what we don't know. What's the area formula for shape 5?
1/2 times height times base times base.
There you go. It's a trapezoid, so there's our area formula. We know the area, 78. 1/2 of, we have the height? X. That's what we don't know. And our bases are what? 6.4 and 13. Okay? I'm going to multiply by 2. What's 2 times 78? 156 would equal x times, what's your 6.4 plus 13? You don't need calculators. 19.4. So all we have to do now is divide by our 19.4. .04?
Yeah.
8.04 centimeters. And what you told me there, Adriana, was a good thing to do. Often we say nearest 10. Well, it's not exactly 8, is it? So if I just wrote 8.0, even though that is nearest 10, probably a little better to go to 8.04 because we can see it's close to 8, not really quite 8. Formula that we're going to use for 6. It's a rhombus. So 1/2 diagonal 1 times diagonal 2. And we know the area is 96. 1/2 of, do I know any diagonals? 14.6, because we're going to need to double that 7.3. And how much? 2x. If one side is x, the other side is x, that makes 2x, not x squared. How do you get x squared? X times x when you're multiplying. That's not what we're doing here. Okay? What I would do here, if I took half of 2, that takes care of it. So I'm ready to get x. All I have to do is divide by 14.6. Let's go to the 10th. 6.6. Was this one in inches? How did I get rid of that 1/2 again? Yeah, 1/2 times 2. They just canceled each other out, went to 1 right there. Number 7. Our shape is a kite, so it's 1/2 diagonal 1 times diagonal 2. So 104 is our area, equals 1/2 of, do we know any diagonals? 2x. How about the other diagonal? 16.4. So again, I can take half of the 2, and that's just 1. All I have to do is divide by 16.4. 6 point how much? 6.3 feet. We found what is missing. From page 793, 1 through 26.